All right, for number 7. Now, part A and part C, they are pretty much the same question. Why are they the same question? Acceleration, yeah, very good. Acceleration would be 0 for both cases. So when we look at an elevator, okay, so if the acceleration is 0, that means the normal force, which is what the scale reflects, or what the scale tells you, will be exactly the weight that you are having. So in the case of part A and part C, they will both be 490 newtons, because in these two cases, the normal force is going to be the same as mg. Okay, or if I want to go one line earlier, or maybe 2 lines earlier, we can say the normal, all the forces in the y direction would be 0. Normal force minus mg would be 0, so normal is equal to mg. And that would be the case for A and C. But what about part B and part D? Okay, so for part B, we have an upward acceleration of 2 meters per second square. So that means our normal force would have to be greater than our mg. But by how much? Well, we can find out the F net, because we know our we know our acceleration. Okay, so F net is equals to mass times acceleration, and the net force will be the normal force minus 490 newtons. It's equal to, did they give you mass? It didn't give you mass. Can you get the mass? By doing (490 newtons divided by 9.8). F is equal to mg, or W is equal to mg. All right, so your normal force will simply get added to the other side. So 490 divided by 9.8, which is 50, times 2, 100, plus 490. So this is the reason why, if you are on an elevator that's going up, accelerating upward, all of a sudden you feel like you get heavier. Your feet will feel some stronger force. You feel like you're being compressed for this particular reason, because you are receiving bigger normal force off from the floor of the elevator. Okay, and for part D, it would be like the opposite. So for part D, we are accelerating downward. So then we have mg, which is still 490 newtons, but then we have a much smaller normal force, because your overall net force should be heading down. So our F net, or all the forces in the y direction, is equal to ma. And if we take downward as positive, so we can still use this, except that we would do 490 newtons minus n this time. So so if you rearrange the variables, you add the normal force to the other side, and this side is going to be 100. So subtract 100 from both sides, so your normal force could be 390 newtons. And that's why when you are well, if the elevator goes down, you have a little bit of feeling like weightlessness, because the normal force is less. Your feet will feel less normal force off the floor for that reason. Okay.